Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the limit of cosine x as x approaches 0 using table of values. This time, we are going to shift our focus on computing the limit of this given trigonometric function, cosine x, as x approaches to 0 using table of values. Somehow, we already know the limit of this, and we have been using the limit of a specific trigonometric function cosine x as x approaches to 0 in our endeavors, specifically on other computations. But let us illustrate that using table of values here to further show its relationship and its proof, so that we could have comfort in using that in other examples. So again, our function here is the trigonometric function cosine x, and then we are going to solve for the limit of cosine x as x approaches to 0. Okay, now our x here could be represented in two different forms. We could use here radian measurement, and we could use here degree measurement. Of course, the radian measurement goes with pi, and degree is of course degrees. But let us set first our calculators or this tables using radian measurement, but instead of using pi's, let us have specific values closer to 0 from both left and right. Let me use here -1 to +1 in terms of radian measure. Make sure that your calculators, as we try this later, are expressed in radian measurement. But definitely, if we're going to use degree measurement, the possible limit will still be the same. Okay, our goal here is to show that the limit from the left of 0 and the limit from the right of 0 are equal, so that we can get the actual limit that we have been using for cosine x as x approaches to 0. Let's have here x and f of x at this point. Let's try the values of -1 from the left, and of course -0.5 as we get closer, -0.1. We may use other values later to further illustrate the relationship. Now, as you include -1 as your angle for cosine, and as you have that in your calculators, please use calculators if you would like to. Plugging that in, you will have here an approximated value in 4 decimal places. You have 0.5403 in 4 decimal places, okay, approximately. You will have this value, but in this sense, we cannot get the exact value of the limit. Hence, we will be using the next values. So as you will try -0.5 there, plugging that in your calculators, you will get an approximate value in 4 decimal places, 0.8776. As you can see, there is a trend already that it gets it increases its value, but we need to look at where it should get closer to, or what is specific value it is approaching to rather. So let us continue with the value of -0.1 as we get closer to 0. Plugging that in your calculator, you will have here approximately 0.950. Okay, now to look into this further, let's include other values closer to 0 for your x. So here, let us try -0.01, -0.001, and -0.0001. Okay, so obviously they are all getting closer to the 0. Now, as you plug this in your calculator, you will get the first. As you use x being equal to -0.01, you will have here approximately 0.99995. I'm just increasing it to 5 decimal places. Don't worry, because I would really like to see, or let you see, the trend here. Because as you use -0.001, it's actually in 4 or 5 decimal places. It's actually 1.0000, which is also this value. That's also 1.0. And of course, this is also 1.000. As you can see, as x approaches to 0, your f of x approaches to 1. This is the limit of your cosine x as x approaches to 0 from the left. Let's examine the values of f of x as x approaches to 0 from the right. As we use the values of x only positive, you have 1, 0.5, 0.1, 0.01, 0.001, and 0.0001. Okay, you can try this on your own, but we will have here the approximately the same values as we use the values from the right of 0. So you will have here 0.5403. You can imagine the graph of cosine if you're thinking of the graph of cosine. So they actually have the same value. For 0.5, yes, you will have 0.8776. To verify this, again, you may use your calculators there. For our next value, 0.1, it's actually, again, 0.9950. And for the rest of the values, we'll be copying the values from the left using the negative of these x's. So you will have here 0.99995. Again, 5 decimal places just to illustrate this further. And you will have here 1.00 and 1.000. Again, you may use your calculators to verify this. Then, as you will use x getting closer to 0, you will have the trend for your f of x also getting closer to 1. This is the limit of your cosine x as x approaches 0 from the right. And we can see that they are equal, and they are both equal to 1. This is actually now the limit of cosine x as x approaches to 0, because our limits from the left and from the right are equal to one another. Again, this is what we have been using for some instances, and we have verified that using this table of values. So this is how we illustrate that limit using the table of values from both left and the right of our value of x, which is 0. Thank you very much for watching. So what are you waiting for? Subscribe now.